Hi, everyone. I'm excited to present this topic on transforming seller onboarding in retail using responsible AI, RAG, and risk management. My name is Bhavnesh Walia, and I'm going to cover a variety of concepts today in this presentation. One will be on RAG, which is retrieval augmented generation. The other one is on LLM-based decision automation. I'm going to provide you the whole user flow and how these techniques have been utilized in this presentation. So the way I'm structured this a project is tenfold. First, why document automation really matters. If you look around in different fields, you always have documents and you need to process them, read those documents. So we'll talk about that. Then we talk about like a user journey of someone trying to open a checking account or a savings account at a bank. How does the end-to-end documentation flow look like? And third, we talk about what are the challenges of processing these documents and how it has evolved over a period of time from 2010 to 2025, what different techniques have been utilized, and what is the way forward from 2025 onwards. The fifth topic is about automation pipeline with the feedback loop. This is more about the architecture of this project, and I'll go a little more into details about it, where we would cover RAG and LLM-based classification and decisioning. We also evaluate our LM metrics through a variety of KPIs, and then towards the end, we talk about the implication or the impact of this project across a variety of industries. So with that, moving on to the next slide. Why does document automation really matters? So as I was telling you earlier, talk about banking, talk about e-commerce, talk about finance or insurance and healthcare. There is just like a bunch of documents that are being created by patients, customers, doctors. One needs an efficient way to process these documents. And since the advent of AI, it has allowed us to make this process much more efficient in terms of extracting the document, extracting the key fields from those documents, validating them, and it could be a structured or a semi-structured document. And this AI would really help us in trying to understand these fields by extracting that information. As I was telling you earlier, it's used across a variety of industries. It is also used in enterprise back offices where we have invoices, contracts that are being generated day in and day out. And why is it even important? One part is today the process is extremely manual, so it's inefficient. So with the advent of AI, it can bring about efficiency. So it would reduce the processing time by north of 40%. That's a huge savings. Second, there is fraud and risk prevention that AI brings about. We need to prevent fake documents or forged documents coming into the system, coming into the platform for banking or for e-commerce. So AI would help us decipher as by processing these documents more appropriately. Then there are regulations. There are regulations within the United States, across the globe, that talk about anti-money laundering, that talk about privacy for documents that are related within healthcare, HIPAA, and therefore you want to ensure that these documents are appropriately processed. Once we have all of that, it can be scaled across a variety of industries. And what happens when the AI, when AI, this particular project starts to process these documents in a more orderly fashion, it improves customer experience. If you go into a bank, you would be able to process or open a checking account much faster compared to the manual process. So all in all, it helps to improve privacy. It helps in better customer experience. It helps to adhere with the rules and regulations that are out there. On this particular slide, what I'm talking about is a user journey for someone who's trying to open a banking account. So the first stage would be they would come into a bank and they would submit a variety of documents. It could be their passport, could be their driver's license, utility bill, whatever is the requirement, they'll come and submit it. The second stage is that you extract the relevant information from these documents. Once you've extracted this information, the investigator or reviewer would fill out like a particular template by using these fields. At the same time, The reviewer would also have to assess what type of regulations pertain to this particular customer. For example, they're trying to open a savings account in New York. There are regulations that are specific to the United States and also specific to New York. So the reviewer would try to pull that information out as well and would see what regulations would be pertinent to this particular customer. And if in the process they realize that the documents are not legible, one cannot read those documents, or there is additional information that's required, that triggers the fourth step where you go onto a customer and you request those additional documents. Once all that process is done, you're okay with the documents that have been received from the customer, then you start going into more granular steps where you start checking whatever the template would look like. Does the name match across a variety of documents? Does the address match with what is being verified on an external website or an external source? So those verification steps, those course verification steps that happen on stage 5 and stage 6. Having done all of that, then the reviewer can make a decision whether they want to approve this particular customer and provide them with a checking account, or would they want to decline and reject that customer. So as you can see, in all the 7 steps, there is human in the loop that's trying to make those decisions. And as you can tell, like, this becomes quite inefficient if you start having multiple hundreds and millions of customers coming in and trying to say open a checking account or a savings account. That's the motivation as to why we need to make this process efficient. And that's where AI, RAG, and LLM came into being. What are the challenges in document processing? A part of it is something that I've already covered in the prior slide, which was how manual the process is. So today, just putting a number to it, 70% of the onboarding work, onboarding time is actually spent in doing these repetitive, mundane tasks, and AI can actually help to make this more efficient. There's a heavy reliance on humans, and as humans, we do commit errors. So as we're working in millions of documents, there is but a high possibility that error would be committed. And then there are like resubmission cycles where customer is asked for more documents or a human has committed an error. So it kind of makes the whole process quite inefficient. Coming to the regulatory complexity, our regulations are changing all the time. To keep up with it, it's a challenge. It's a whole new project. So by introducing RAG in this, essentially what it's doing is it is automatically pulling the most relevant clauses from a variety of regulations, be it in a different geography or not, and it brings that together along with the extracted information from the documents, and it combines this together to allow LLM to make efficient decisions. The third is, as you bring in AI, you bring in automation. It helps to reduce the risk, and it helps to scale the project across multiple applications across different industries. Today, the processes that we have are extremely manual, so that's the struggle and that's the limitation that our project, our AI, machine learning, and RAG is trying to solve for. Let's now talk about how this whole process has evolved over a period of time. So think about 2010. Before that, there was high reliance on manual document processes, where again, a manual reviewer is going into the system, looking at the documents and copying things over. Come the digitization phase, which is like the 5 years, 2010 to 2015, we started using a lot of scanned documents. We started putting some rules into place to ensure that things are complete, they're formatted properly. Again, a leap happened in 2015 to 2019, where they started using optical character recognition and robotic process automation, which essentially means that you're automating all steps that are extremely repetitive. That's done through RPA. That really made things quite efficient back in 2019. And then come 2020, we started having some bit of AI introduced into our document understanding. And that's where layout aware models came into being, where they were able to go into the documents, identify what is a name, what is an address. It was able to look at text visuals, spatials to ensure they are understanding what the document looks like. That happened in 2020. Come 2025, another layer of complexity is added to it. Not only are we able to read those documents, but also we are incorporating retrieval augmented generation, where we are pulling the relevant clauses that pertain to a particular customer and helping along with the data extraction and the RAG helping to make these decisions more efficient and automatic. Let's move on to the 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 end-to-end document automation pipeline. So think of it as three stages: the data processing, pre-processing, layout prediction model, and then the final one, the RAG plus LLM inference pipeline, which is the novel part of this particular solution. So data pre-processing. One, it ingests the data. Think of your passports, your driving license, any other document that's being ingested. But obvious, there are a lot of personal information on there. So you want to ensure that that information is anonymized and it cannot be used for any purposes other than the purpose of opening an account, opening a credit card application. So we want it not to be misused. The second one is the layout prediction model. Now, once these fields are extracted, one needs to make sense of what is being really extracted. Is it a name? Is it an address? Is it a bill? What does it really stand for? And that's where layout prediction model really comes into being. Here we tried multiple models. We tried the layout LM model, we tried the donut model, and we evaluated from these models which one was actually giving us a higher precision and a higher recall, because those are the performance metrics that we want to look at. In this case, it was the layout LMV2 model that came out to be much superior than the other models that we tried. The third stage, the RAG plus LLM, is one of the most interesting stages. So after the after the extraction has happened, then an automated query plus context generation happens. Where it does is, for example, somebody's opened an account, they've submitted their passport, they've given their name and address, and now we want to see what else needs to be verified. So we'll pull the regulations that are pertinent to this particular customer and bring in those clauses together. Once we have that information, LLM, what it does is it follows a sequence of steps, a template that we provide that verify the name, verify the address, verify the income, look at any other accounts that they have opened in the past. So there would be a whole template of questions that the LLM would go through one by one and ensure if it's completed or it's not completed. Once all of that is done, it would spit out a decision that you want to approve or you want to decline. And along with that, it would provide you as a rationale what steps it took to come to that decision. And which is very important just from an understanding perspective. At the same time, there's a feedback loop, which is important. One example would be regulations have evolved over a period of time. Now, are we keeping up with those regulations or not? Or if there's an edge case that has been identified, one wants to ensure that you train the model with those edge cases so that a mistake like that doesn't happen in the future. So you need to have human in the loop for this particular process. And that's where the feedback loop of continuous learning comes into the picture. All right, moving on to the data pre-processing. I sort of covered this in the prior slide, but out here, just going a little more granular here, variety of documents come into the picture. OCR, it's essentially converting these documents, this information into machine readable format. So for example, name is Maria, date of birth is 1987, company is Retail LLC, and it was registered in 2022. Once that's done, then comes the layout LM model. What it does is it looks at textual, spatial, and visual embeddings of these tokens to really understand the document layout. And it recognizes entities and maps these key value pairs. Once all of that is done, what has been extracted is business information, seller information, billing information, and it could be a different use case for everyone. Like for a checking account, savings account, it could be the name of the customer, their address. In this particular case, it is somebody who's trying to sell on an e-commerce platform. The next one is about data anonymization. And I told you why this is important. It's important because there's too much of PII information here. So there are tools like Presidio, Spacey, and regex that help to anonymize this information. So for example, Bhavni Shvalia in a document would then become name underscore ID 23, where essentially you will not be able to say this is Bhavnish. This is just like a generic term. But at the same time, you ensure that the mapping is retained at some point in the background so that if you want to really map it back to me, that connection still exists. But as the data moves through those pipelines, nobody can essentially use that PI information for anything other than the purpose of opening a checking account. This is about the RAG framework, which is the novel part of it. We've done this in two stages, the semantic retrieval and the cross-encoder re-ranking. So let's talk about the semantic retrieval. Someone trying to open an account, and we'd like to ask them, does the application tax ID match? What it does is it picks out all the rules and regulations around tax ID from the regulations and pulls it in. So no matter if it's slightly related or highly related, it would try to pull all those regulations in. So it would ensure high recall. But what cross encoder does is it helps to rank based on what is really a priority or what is the most relevant clause for this particular activity. So essentially, something like applicant must not have unpaid tax is very relevant. However, tax documents must be retained for 7 years is not relevant. So it would try to push that down. So it will rank all these clauses that have been pulled, but only the ones that are towards the most priority will be put on the top. The ones that are not relevant will be put at the bottom. So with that, it balances both the recall and precision, what we also call coverage and accuracy. All right, this is an example that I've sort of covered in the prior slide, but I just want to make sure just how I talked about this. So there were 5 queries that were extracted. The tax document must be retained for 7 years was the first query that was extracted. And then the fifth one was VAT refund eligibility for tourist. What cross encoder has now done? It has pulled out the relevant ones, which are highlighted in green to the top. And the ones that are not too relevant, they're pushed to the bottom. So in this case, the tax ID must be verified against official records is important, it's relevant. Applications missing tax identifiers will be rejected, it's important, and that's the reason it's pulled up. On this particular side, we talked about how the wireframe looks like. So someone has a case ID and their case ID would be 0198. And our OCR has, along with layout LM, has been able to extract a variety of fields. And then those fields are used to together to create a query test after the OCR has been done. So for example, this person is country of issue with Switzerland. It's a passport with the expiration date of 2029. RAG, what it will do is it will extract all the relevant queries that it thinks, and then cross-encoder is going to rank these queries. So customer identification must rely on valid government issued photo identification. That's the query that's going to be pulled. And the LLM, in this case, FLAN T5, is going to ensure that it's completed, that the passport that they've been provided is actually valid, it is government issued, it has the photo. So LLM will keep going step by step through the template of all these regulations that are relevant, and then would provide like a decision whether to approve someone or to reject someone. In this case, it's approved this person. What it says is Swiss passport is valid, jurisdiction complies with AML regulations, ID and birth date have been verified. So that's the reasoning it has provided. So this, what it does, it has done in this process, it has made things quite explainable, transparent decisions with clear traceable reasoning. It's also scaled seamlessly across jurisdictions with evolving regulations. In this case, we've taken Switzerland. We could have taken any other country, any other city as well. It was able to pull out the relevant regulations from there. And it's reliable because it would reduce the human errors through consistent checks. We do not eliminate humans from the loop. We always have them to ensure that the the solution is performing as intended. So it's really important to have them continue in the process. This towards the end is the how do you evaluate the LLM is working correctly or not. So the first one is the structured output rate, where we measure the how often results follow the required schema. Then the second one is the average reason length. It captures the level of detail in explanations. If it's too short, it's going to miss some relevant, important information. If it's too long, then it's very difficult to follow. So you want to have the right length of that explanation. Third one is interpretability. So whatever results that are being generated by the solution, it has to be easy to understand by a human because human reviewers are going to look at this document. And then would also like to understand how many cases or malformed cases were skipped because LLM was not able to come to a particular rationale. It could be a document was missing. That's the reason LLM was not able to come to a particular decision. So you want such malformed cases to be limited or small in number as you decide on the LLM that you want to choose. All right, so this is the business impact. So given what we did was a proof of concept, so there are certain ways, certain KPIs that one can look at. The number of hours saved, annual cost saving, how accurate are the decisions? Were they rework that was needed? So if you look at the bottom right diagram here, you would see the yellow line, were we to do a manual process? In that case, the estimated hours saved are going to be limited. It's going to increase as you start bringing more documents because humans becomes more efficient, but it's not at the same scale as LLM, which is the blue line. And now that saving increases manyfold if you start bringing RAG into it, because RAG is able to pull the relevant clauses from the regulations as well, and that's where the green line comes into the picture. So again, what we are bringing about is efficiency, and it's scalable across different industries. It's also scalable across different geographies because regulations differ basis on geography as well. All right, so this is the last slide. So the applications of this solution. Wherever there is a document ingestion, there are documents being circulated, there is a need for structured extraction. There is a need to retrieve the rules, clauses from these regulations, and there's a need to make these decisions. To provide a rationale is important because it improves auditability. How did someone come up with a particular decision? What checks they had done prior? So in healthcare, there's a patient intake and eligibility. There is clinical trial screenings and regulatory submissions. There's regulations around HIPAA uh, that provides, that tells about how patient information needs to be handled. So a lot of documents get created there. Finance, I've talked about here in this presentation about how somebody wants to open a checking account or a savings account. It could be a loan underwriting. It could be monitoring fraudulent activity or an insurance claim as well. The third one is legal. Contract reviews take a long time. There's just a lot of documents that are presented during that time. And one needs to perform the litigation discovery. So there's a repository of cases that have happened, and one needs to understand how that case is related to this one. So retrieval-augmented generation is able to pull that information in. When you talk about public sector, this just like from a license application, tax document processing, immigration or border control, visas, there's just a lot of passports in this case, just a lot of documents in this particular respect that can be processed through layout LM. And then you can augment that with RAG and be able to come up with a decision when you layer in LLM in this case. And the last is seller onboarding or to list products on an e-commerce website, also to moderate content because you can read through those texts and be able to understand what that really means. With that said, that's the end of my presentation. I am I'm honored to be speaking to you. I'm happy to take questions.